Welcome back to our video workshop series.
In this section, we'll discuss the differences between climbing turns and switchbacks.
And we'll explain why climbing turns are almost always the better way to go.
That's right. Climbing turns make way more sense on so many levels.
But before we dive in, we want to emphasize that designing a great trail is like solving a big puzzle. Every environment presents unique challenges and opportunities.
The more familiar we are with the terrain, the more likely we'll be able to provide for the rider's needs while protecting the landscape. And sometimes, despite all our efforts, we don't get everything perfectly right.
Sometimes we have to sacrifice some of the wow factor in order to protect the environment. And that's because a sustainable trail beats no trail, and sustainability trumps rider experience.
Okay, now on to climbing turns. If the side slope is less than 25% and there's room for a curve radius of more than 8 feet, locating a climbing turn is almost always a better alternative than a switchback. Why? Climbing turns maintain momentum, and they're almost always easier and more fun to ride on.
A well-designed set of climbing turns harmonizes with the landscape and provides greater flow and more fun factor. They have less tread impact, which makes them much easier to maintain.
Due to the nature of climbing turns, the middle of the arc will be on the fall line and will pick up water. To mitigate this, it's essential that the water be drained off the trail before the top of the turn and immediately after the bottom of the turn. We do this by using a grade reversal, which we talked about in the previous section.
On steeper slopes, large rocky outcrops or an uprooted stump of a large tree can provide a flatter area for a climbing turn. Keep in mind that climbing turns should have a smooth and constant radius. Don't try and square them off by making a sharp turn at the bottom and then going straight up, only to make another sharp turn at the top. That defeats the purpose of a climbing turn.
Don't lose sight of what type of vehicles your trail is designed for, because tight climbing turns can be ruined quickly. This can be minimized by making the radius as large as possible. We recommend a minimum of 35 feet.
Now let's talk about switchbacks. Sometimes they just can't be avoided. If your terrain is steeper than 25%, or it has a rocky, gnarly terrain that won't accommodate a climbing turn, then a switchback is your only option.
By their nature, switchbacks have a radius of less than 8 feet and can be very challenging to ride if they're not designed and constructed properly.
Some designers install switchbacks even when they could use a climbing turn, just to increase difficulty. A switchback is not a challenge feature and should not be used as such.
Why? Because they're expensive to construct, even more expensive to maintain, and most riders don't like them because they're difficult to ride and create severe tread impacts.
Switchbacks consist of 3 parts: a lower approach, landing or turning platform, and the upper approach. It's essential that switchbacks have a constant radius that's as large as possible, because without one, they're extremely difficult to ride.
Constructing switchbacks requires significant excavation and embankment in order to make a proper radius and flat landing. This often requires retaining walls, which increase the cost and complexity of the installation. And if you don't make them right, they become unstable structures that are difficult to ride and will require constant maintenance and repeated reconstruction. That's just very unrealistic and no fun.
And now we're going to give you some practical tips for laying out turns in the field. We'll show you how to gather critical information and tried and true methods you can use without a degree in engineering.
Well, that's good news. There are 2 ways to lay out a circular curve without instruments: the offset method and the radius method.
First, the offset method. Any 2 points make a line, and any 3 points can make a curve. The starting point of a curve is called the point of curvature, or PC. This is point 1 and where we need to insert a pin flag or lathe into the ground.
Next, we walk ahead 15 feet, X, staying on the line between point 1 and the tangent behind it. From that point, measure 5 feet, Y, in the direction of the curve, and then insert another pin flag or lathe at that point. This is point 2.
Now you can visualize how the curve is taking place.
Continue this process until the curve is completed. You can add intermediate flags as needed between points and adjust any that look out of place.
To make a tighter curve, just increase Y, or you can also increase Y and decrease X. Once you practice this technique a few times, you can use steps or paces instead of measuring the distance.
The other method to create curve without instruments is the radius method. For this method, the radius r of the curve is known. If you don't know the radius, you can estimate what will fit the site and adjust up and down as necessary.
Here's an example. Assume a 25-foot radius is needed. From the starting point, turn 90 degrees to the back tangent and measure 25 feet in the direction of the curve and insert a pin flag or lathe. This is the radius point of the curve. To make sure your radius measurement is accurate, you can use a piece of rope or ribbon that is cut off to length equal to your desired radius. Have a partner hold the rope or ribbon down at the center point of the turn, or stake it down and then place your pin flags at the end of the ribbon. A logger's tape is another great tool to use when laying out turns.
From this point, measure out 25 feet and insert pin flags along the arc of the curve. If trees or bushes are in the way, make several arc measurements and add intermediate flags as needed. Then adjust any that look out of place.
That concludes this training section. Please take a few minutes to review the pros and cons of climbing turns versus switchbacks.